Imagine holding a camera lens that captures distant galaxies, tiny insects, and priceless memories. But where does that incredible precision begin? Most people never think about this, but a single professional lens contains dozens of parts working with microscopic precision every second. Think about this. Light travels nearly 300,000 kilometers every second. Yet this lens bends it with astonishing accuracy. Behind every perfect photograph stands an enormous global supply chain stretching from remote mines to spotless optical factories. And this is where it gets truly extraordinary. Every flawless image begins as ordinary rocks buried deep beneath Earth's surface. Our journey starts in high-purity quartz mines across the United States, Norway, Brazil, and China, where optical-grade silica begins its story. Engineers demand silica purity above 99.99%, because even tiny impurities scatter light and ruin optical performance forever. Gigantic crushers reduce massive quartz boulders into smaller fragments before advanced purification removes unwanted iron, aluminum, and moisture. Chemical washing and high-temperature drying leave behind brilliant white silica powder, ready for precision optical glass manufacturing. But silica alone cannot create world-class optics. The secret hides inside rare minerals collected from several continents. Lanthanum from Australia and China helps produce high refractive glass, making sharper images without dramatically increasing lens size. Factories also blend boron oxide and carefully measured metal oxides, creating glass with extraordinary clarity and controlled expansion during heating. Each ingredient travels thousands of miles inside sealed containers before reaching factories in Japan, Germany, and Thailand. What happens next surprised even experienced engineers, because transforming these powders into perfect glass demands unbelievable precision and blistering heat. The furnace doors close and temperatures climb beyond 1,600 degrees Celsius, or 2,912 degrees Fahrenheit, until the raw minerals glow like miniature suns. Powerful ceramic mixers rotate around 25 revolutions per minute, blending molten glass for nearly 24 hours until every ingredient becomes perfectly uniform. Imagine standing nearby. You hear deep mechanical hums while scorching air radiates through layers of protective shields and insulated walls. Next, the molten glass pours into precision molds where cooling begins so slowly it can last several weeks without interruption. This controlled cooling, called annealing, removes hidden internal stress that could crack the glass months or even years later. But here's what nobody tells you. Nearly 15% of optical glass never survives this demanding cooling process. Diamond saws spinning around 3,500 revolutions per minute slice giant glass blocks into circular blanks with astonishing precision and almost no vibration. Robotic arms lift each fragile blank, while laser scanners instantly measure thickness within only a few microns of tolerance. Now the real artistry begins. Giant CNC grinding machines sculpt every curved surface using diamond tools and flowing coolant. Grinding removes nearly 90% of excess material before polishing transforms rough surfaces into crystal-clear optical masterpieces. Soft polishing pads coated with cerium oxide glide for hours, removing imperfections smaller than wavelengths of visible light. Every polished element sparkles under inspection lights, revealing surfaces so smooth they appear almost completely invisible to the naked eye. Then comes an invisible superpower. Vacuum coating chambers add microscopic anti-reflective layers only nanometers thick onto every surface. Inside nearly airless chambers, advanced plasma transforms vaporized materials into perfectly bonded optical coatings with extraordinary durability. Finally, technicians assemble dozens of glass elements, precision spacers, motors, and aperture blades inside dust-free cleanrooms. But perfection still isn't guaranteed. Every completed lens now enters the most demanding stage. One invisible flaw can send weeks of precision work straight to recycling. AI vision systems photograph every surface, searching for scratches, bubbles, dust, and coating defects smaller than human hair. Laser interferometers measure each optical surface with astonishing precision, detecting errors smaller than 1/4 of visible light's wavelength. Most premium manufacturers reject nearly 2% of finished lenses, even when ordinary photographers would never notice the difference. Think about this. Engineers measure alignment within 2 to 5 microns, thinner than a single red blood cell. Next comes autofocus calibration, where robotic systems repeatedly move tiny focusing motors thousands of times without making a single mistake. High-speed test cameras capture detailed resolution charts, proving every lens delivers razor-sharp images from center all the way to every corner. Some lenses spend hours inside climate chambers, cycling between -20 and +60 degrees Celsius to verify long-term reliability. Powerful vibration tables simulate years of travel across rough roads, aircraft cargo holds, and demanding professional assignments. Water-resistant models face powerful rain simulations, while dust chambers challenge every seal protecting delicate optical components inside. But machines cannot judge everything. Experienced technicians still inspect every image with trained eyes developed through decades of craftsmanship. And this is where human skill still beats machines, because experienced experts instantly recognize subtle imperfections algorithms sometimes overlook. Only after passing every inspection does the lens receive its final approval. But its worldwide journey is only beginning. Every approved lens now joins a global industry, producing, over 120 million interchangeable and fixed camera lenses each year. Together, the global camera lens industry generates an estimated $18 billion annually, driven by photography, filmmaking, security, science, and smartphones. Japan leads premium optical manufacturing, followed by China, Germany, Thailand, and South Korea, each contributing remarkable engineering expertise. Hundreds of thousands of engineers, machinists, chemists, robotic specialists, and inspectors work together to make every perfect image possible. The journey began in the 19th century with handcrafted brass lenses. Today, AI and nanotechnology shape optics beyond early inventors' imagination. Over the last 50 years, computers transformed nearly every manufacturing step, improving precision from millimeters to astonishing microscopic tolerances. Within the next decade, AI-guided polishing and quantum-inspired optical designs could create lighter, sharper, and even more powerful camera lenses. Did you know some premium lenses contain more than 20 individual glass elements, each polished almost perfectly before final assembly? Did you know anti-reflective coatings measure only a few hundred nanometers, yet dramatically increase light transmission and image contrast? Did you know a tiny grain of dust trapped inside a lens can force manufacturers to completely disassemble and rebuild it? The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.